the refiner operations are single most important within the industry. Very highly, most energy consuming of all the paper making operations. And the main problem is the internal environment. What happens inside is not very much visible to operator. So it makes different operators operate it in a different way, and to over the with segment life and all that, the situation inside changes, which is not very clearly visible. And even the performance of the refiner is evaluated only twice a shift at the maximum, so which is not enough to make a very efficient operation of the equipment of this size. Haber being in artificial intelligence, the artificial based automation is providing
Mr. Ram, you have
very
to be a
great.
bit louder. Mr. Ram, please be a bit louder.
Yeah. So artificial intelligence is allowing us to is giving us a lot of tools in our hand and able to make a lot of statistical analysis. But what we will be speaking here is I will not go deep into about what is artificial intelligence, because we have already provided a speech in IPTA platform regarding that. That records are available. And also, if for further information, you can see some blogs on our website, haberwater.com. So I will be just focused, because the time is short, and keep it limited. I will keep the focus on what are the subject around the refiner, on the process importance. So ultimately, we are here. What we are trying to do is trying to evolve a good package that you are just by doing this, you are not only operate your refiner in the best form, but you should be able to also link your paper machine operations and also certain proper paper properties which are related to, of course, paper making is a complex thing where refining is also just a part of it, but we will be providing a good insights of what a part of refining is also affecting your paper machine operations as well as paper properties. So we'll see deeply as we go through these slides. So you are all more masters in refining. So, but there's just a catch up for a beginning of the call that ultimately what happens inside the refiner, if either too much energy or a bad operation can cause fiber shortening. And there is something called external fibrillation and then internal fibrillation. There's the amount of energy that is given for refining very much impacts these as well as the paper properties. So ultimately, what do we get out of the objective of refining automation is consistent freeness. This is very difficult to get in the absence of substantial amount of data being generated, which is very difficult to know, and typical there will be some process variations. In spite of this, how to get consistent freeness, that we will see that. And energy. Before we, of course, it's very common to talk about savings in power. Even before that, it's very important to understand how much energy to provide for a particular, because each day it may be changing. So what could be this one, and there will be a lot of factor of safety. If you want to give 400 people, maybe keeping 430 or 440 kilowatt also. So there is a blind area.
So how to do it without this? You have a loose connection. It is making it voice. Please see the audio. There seems to be somewhere a loose connection in your.
Okay.
I think please see the plugging part or the somewhere. I don't know where this loose. It's making sound. Yeah.
Yeah. Just a second. Is it better? Yeah.
Much better. Please go ahead.
Yeah. So what is it that around most important thing around refiner automation is first thing is consistent feed to refiner in terms of flow, consistency, and also the recirculation rate, and differential pressure across the refiner, and the energy imparted into the fiber. All these three make it very important for a consistent operation of refiner. And current manual, generally the maximum that is done is a manual evaluation of freeness, and that also that there is certain time which takes to get the freeness results, and at the maximum 2 times per shift is done. This is quite insufficient. So unless we get consistent freeness, we cannot get consistent paper strength or quality. So what is this? So what we have designed is based on artificial intelligence is something called a refiner management suite. In this, the core area we have tried to include every aspect around the refiner. That is the hydraulics. First thing is more important, as I said, is the hydraulic stabilization of process. That is the flow, consistency, and the recirculation, how you balance the refiner. That forms a very, very important this one. For this, every system has to be separately evaluated and certain modifications need to be made if required. So that done, then there is a calculated energy management through artificial intelligence. There are certain lot of options for virtual analytics based on which you can get very useful data, or this one, then process assurance. Then we have also included the maintenance aspect around the refiner. That is the asset protection as well as condition monitoring, like refiner bearings, motor bearings, because these are the things that are also affected when things like plate clashing, etc. are done. And if there is any specially that you are doing, it basically we can add any sensors that you have in the field, and we can analyze the input like any your ash flow or anything like that. Basically any sensor, or we can also provide that. So how that impacts your final net refining as well as paper properties, that can be done. Then you are linked to paper making, your paper grades and properties. And if needed, this can also be expanded to include, instead of a freeness analyzer or addition to a freeness analyzer, fiber morphology unit can also be added. And you can, with this, you can even evaluate different refining enzymes or even different tackle manufacturing. So in a way that we have designed it, that every aspect around the refiner is covered in this package. So if you see the approach, how we do to a refiner management suite, the most important part, core central hydraulic stabilization process, you have process stabilization. You have to control basically flow, consistency, pressure, and recirculation rate. These forms a very important part of managing the refiner. And the influences is pulp pH, viscosity, and pulp strength. And energy optimization, how to evaluate and they directly give only that much energy that is required to manage the fibrillation. And also measuring, frequent analysis of freeness results. The online freeness analyzer will be added to this. You will get, depending on number of refiners, you will get in as much frequency. So I'll not go through each one of these, but what we have done is to consider, these are theories that are available everywhere in public platform. And what we considered is just basically to stress on the importance of each and everything, and what are the number of sensors that we take into this operation. This is basically to show the importance of this. You can go through this at leisure. So in this wholesome approach, we have divided into 4 parts. One is the monitoring and flag input variables. That is, the first thing is what changes in the input, the consistency transmitter in the feed, the flow inlet and outlet pressure signals, and also the power signal from specific energy consumption. This is the most important one. This will be constantly tracked. And then we track segment life and real time. So the segment loading, the new segment loading date and all will be entered there, and it will be tracked over the life. And there will be gap sensors. So we'll see the change in gap depending on loading as well as the energy given. We can see how the segment is influencing the properties. And also the maintenance aspect, bearing conditions and motor conditions. Yeah. Yeah, I think I'm getting an echo. Can somebody mute, please?
Dr. Ram, there is
process control.
Dr. Ram, people are telling that there is a background disturbance on your audio. I am once again requesting all the delegates, please mute yourself. And Dr. Ram, please see if you can do better on the audio.
Yeah, I'll try without my earphones. I'll just remove, probably earphone is stopping it. Yeah, I think it is.
Yeah, Dr. Ram. Go ahead, please. Nobody can hear you now. Dr. Ram. Dr. Ram, nobody can hear you. Dr. Ram, nobody can hear you. Nothing is.
Yes. Is it now?
Now, but there is an echo sound. Are there more than one laptop in your room? More people are sitting?
No. Yeah. No.
Yeah, now it is okay.
Microphone is removed. Same as system. I've selected.
Yeah, it is
Speaker.
okay now. Go ahead.
Yeah. Thanks. Sorry about that.
But there is a background noise of your office, or I don't know.
No, there's no noise here.
Okay.
Observe no noise here.
Okay.
You just mute yourself. Let me try from a different system. You can do
OLG, lot of people are still kept their mic open.
Yes, I agree with you. There are so
By
many
name,
times.
you please. By name, we
Once
have to tell.
somebody, Mr. Gunwante Masane, please switch off. Mr. MS Lithik, please switch off your audio. Mr. Mahesh B, please switch off your audio. Mr. Mahesh B, Mr. Kirti, please, yes, Mr. Then Galaxy M01, please switch off. Yes. Mr. Gunwant Masane, please switch off your mic. Please switch off. Otherwise, if there is a disturbance, everybody gets disturbed. Mr. Ram, now you have to unmute and go ahead. Yeah.
Yes. Unmute.
Now there is an echo of your own system.
Switch off. Yeah, now it's better.
No, there is another laptop which is there another system in there? You
Yeah,
switch
now it's
off
better.
the- Yeah, but there is another laptop sitting in your room. Or the desktop which is sitting and its speaker is on.
Maybe you can switch off.
Yeah.
System.
Other system, take it away, and all other system, you stop the video and audio and speaker both, 0. Now you
Yeah,
go
done,
ahead.
sir. Done.
Yeah.
So can we start?
Oh, there is another system in your office which is disturbing. Mr. Apu Das, please mute yourself. Mr. Apu Das, please mute yourself. Yeah. Mr. Ram, please try.
Yeah, thank you. Now it's better? Yeah.
Yes, it's okay now.
Yeah, sorry for it. Yeah. So as we get, then the process control, so online freeness measurement, as well as an optional fiber image analysis can be added. So these are the 4 aspects where we have divided into it. So it forms a complete package for your refining. Yeah.
Dr. Ram, there are 2 red lines are coming on your presentation. So you close the presentation and restart it.
Presentations.
There are 2 lines visible, red lines.
Yeah, red line, yeah, that is coming. I don't know why.
Okay, ठीक है.
Yeah, I don't know where from it's coming.
You can go ahead. No issue. You can go ahead.
Yeah. So then, as I said, we can do the virtual analytics as well for process assurance. Basically, we assure that it's done with as per desired this one. So here we can compare as we collect data. We can compare different things. First important thing is the freeness you collect, and we can ensure that it is kept within a certain target bandwidth. And what are the things that, depending on your furnish, what are the things that is influencing is most, depending on your piping design and everything. Identify the best consistency range. We can make a comparative graph trends around what is the consistency range and what are the freeness that you get. It can be collected, and then artificial intelligence also, due to some mathematical deductions, will identify the best consistency range that to operate your refiner. Similarly, throughput, and identify best back pressure points. Each of these properties, process properties, the trends can be developed and we can identify the best areas to operate for each of these. Yeah, and then we can link the machine operations also to refining part. And basically, we are measuring the freeness after the refiner and manage the refiner operations. Apart from it, generally, after the refined chest, there will be some broke that may be added before it reaches the paper machine. There could be some save recovered fiber that may be added. So these things may once again affect the freeness of the pulp before it reaches machine chest. So if required, an additional samplers can be used after the machine chest or mixing chest as well. And then we can, depending on the provisions made in your paper machine, or we can add certain provisions. We can take certain very critical data like grade, GSM, speed, even the hash flow, everything that can be taken, and Cooch vacuum, on our press loads, anything. Whichever you think that if against a survey of each of the paper machine, whatever you think is affecting the wet end formation of the strength properties of your paper, these things can be loaded and then analysis can be made. How it is, what is the how refining is affecting this. Similarly, paper properties, we can take each of these paper strength properties. Ultimately, refining affects the density of the pulp, and density in turn affects many of the strength properties of paper. So I listed some, it could be some others like bulk, etc. also. So depending on that, whatever the duration to get down, then a manual testing is done. These test results can be uploaded
office
to
mein aao ek baar.
All this uploaded. There are many ways in IT now that you can upload physical data into the cloud. So this provision, if it is available, fine, or we can also make some provisions. So every year, suppose every year you have a test result coming in, this can be uploaded onto the Elixir. And for that, previous 1 hour data will be analyzed along with the refiner operations. And depending on that, we can identify paper properties. This could be especially useful for specialty papers or high grade board grade papers. And whatever be the type of refining, it could be by application pulping or stock preparation. This is applicable to any of the refiners. There is a certain importance to each of these refiners by type or position. So all this can be monitored here. And so as we go into the subject, one of the things that these are fundamental to doing any automation, that is like computer language only, garbage in and garbage out. So it is very important that we focus on what is actually stabilize the input variables. For that, one of the most important thing that affects the performance of refiner is a proper flow, stable and centered rotor, because most of the rotors are hydrodynamically balanced in endurance and all. So proper flow, then and each of the either low flow or high flow affects the performance of the refiner. Based on that, we will be monitoring the flow meter, and how we control the flow to the refiner we'll discuss in the coming slides. And importance of consistency, again, as it is known, very important for hydraulic balance and even to segment life, and how, because refining consistency is directly related to getting the fibers onto the bar edge. So performance will be exponentially better in terms of consistency. So we will choose the right consistency range. We can experiment and choose the right consistency range based on this analysis. So these are the rotor, most of the refiners, the rotor, the central tri-disc refiners and all that, the rotor is centrally balanced. So the stock flow is very, very important to maintain the stock flow and a proper consistency. So the root cause for flow variation is, these are the possible effects. One is of course the variation from the pulping street. This can be optimized to the maximum. In many places there is a lack of level control. The chest level control greatly affects the pumping ability of the pump because of the higher consistencies. So it's very important a good level control is managed, and the level is also maintained at a very nominal level from a very small bandwidth. And retention time of the chest, the rightly sized chest is also important. And also type of flow control, whether it's a VFD in the pump or a control valve, depending on that, what are the plus and negative effects can be taken into account, because the way each of these controls the flow is slightly different. And root cause for consistency variation, the variation again from big street, if any, and then many places they think that after all maximum the pulp is coming back from machine into the stock preparation area. They connect a lot of interrupted flow sources. That is, you will not have a steady flow of pulp into the chest. It will be like every 20 minutes, maybe some surge overflow tank or anything that comes extra or waste from the paper machine is added. These are the things that need to be avoided. And unpredictable flow sources. In some cases, there are even people who are connecting directly couch pit pulp or anything like that, which nobody knows when it will increase the consistency, the flow, when it will be available. So a lot of these unpredictabilities around the refiner feed chest should be removed. So the refiner feed chest becomes like the heart of the operation of the automation system. So this has to be dealt with with a very sharp eye. So this is an ideal flow and consistency control ahead of the refiner. And it's a very, the importance of tank level also. Many people operate 0 to 60% or 0 to 40% down. These things can be avoided because each level changes affects the performance of the pump greatly. And this is a typical setup where there will be what we prefer is for the refiner feed pump, a VFD control. And then there will be an Alexa control system that will be that will take all the inputs from the parameters, and a consistency transmitter and a feed transmitter, and all the differential pressure valves are connected to a Alexa control system. So this is the simplest form of representation of how this automation will be working. So Freeness analyzer sampling, it depends on, we have to make a survey of each of the system depending on number of refiners. It is a typical like a 3 refiner in series, like we can take for a input pulp, as well as usually depends on the Freeness analyzer, you get the number of samplers. There are also other models where you can increase the number of samplers. Basically, we have to work out how many points you need a sample to be tested. But the only thing you have to keep in mind is the more sampler you add, then you have less time within an hour. Like if you have 4 samplers, like one particular position, you will get 15 minutes of data. So it has to come in cycles. So this can be managed. And typical from most of your field instruments can also be connected to the Alexa control. And apart from anything missing can always be added. And like we said, because of the interrelationship, all these data are very important in identifying what is the root cause of the problem around the refinery. So far, any questions? Shall I proceed? Yeah. If there are no questions, I'll continue. So major concepts in control systems is like pH. But these are again, see, there is nothing that we are changing theoretically here. We are only enabling the system to get more data so that when you have more data points, your interpolations are much better. So in the sense that these are all theoretically proven things, and a last mile pH control system, particularly whatever you do, definitely because of the chemicals involved and all the process variations involved, the pH may be varying a bit. So we recommend a small level, whatever is the chemical that you use for your pH control in your pulping system, same thing can be used here, but in a very small way to control a very small variations, just ahead of the refiner feed pump or just after the refiner feed chest. So then an FCV present, there are many places where the outlet of the refiner is actually, there is a flow control valve and then it is controlled. But one should remember the refiner feed pump itself has a typical QH curve. So any changes with Q will have a change in the AH or similar and vice versa. And whereas same way the refiner is also works similar to a pump only. And although very inefficient one. So, but when you have a flow control device and suddenly you constrict or throttle the flow at the outlet of the refiner, you make inadvertently, you make a change in the pressure around the refiner, which in turn can affect the differential pressure around the refiner. That's why in some cases, particularly in series or in parallel, sometimes when you control the output flow, if there are 2 or 3 refiners, one refiner is not very equally loaded, then it becomes highly loaded, or there is a plate clashing or a abrasive heat generation happening. This is observed in many cases. So one of the things we recommend is like FCV present in the outlet can be interchanged to inlet, or we can have a VFD for the refiner feed pump. And the set point for this refiner can be included, can be arrived at from your refined pulp chest level or so. It can be anyways can be made either as a standard set point, or it can be the level control of your refined features. That can also be a set point can be generated for the flow, and VFD controls the flow of the pulp. Similarly, a PCV at the inlet can be installed either at the inlet or at the outlet, but the only marginal difference adjustment only. And a recirculation line must be connected. It's very important that at least theoretically as well as several practical attempts by even TAPI, everything has shown the recirculation rate must be between 8 to 12%. Then only the benefit of already a refined pulp going into the refiner is derived. This one, many places, it is not done. It's less than 5% is recirculated, or in some cases the recirculation is line goes back into a very long route, which by the time once it is sometimes in the top of the refined feed chest. So there it will lose its ability to give the benefits. So it should be come in a very short loop, either back to the feed pump suction or into the just ahead of pipeline itself ahead of the refiner. And LT at the refiner outlet must control the, as I already mentioned, through the flow through the VFD, and not restrict the flow control wall at the outlet of the refiner. So these are some of the problems with when you have a refiner in series. If you have a flow control valve at the outlet, and if you're just managing the level of the refined feed chest, then the problem is the third refiner is very likely to have a, because the inlet PCV of the first refiner will be maintaining a certain pressure, and then there will be subsequent pressure drops around each of the refiner. This I have not shown a very detailed view. Sometimes even between the first and second, there is also a pressure let down also being done. Relief is done. But all said and done, each refiner will be working whatever be the level at a differential pressure points. At a set of differential pressure points. Particularly when you control the FCV, the third refiner will very likely handle a uneven differential pressure, due to which it may get heated up, or a plate, a higher wear of the segment can happen. So then energy input. So there are a lot of theory around this, and the most important thing is to calculate the no load of the refiner. So basically, no load is defined as in the absence of pulp, what is the load that is taken by the refiner. But it is easier to say in theory, but in practical, it is very difficult to consider, because once you have only water inside, unless you have furnish inside the refiner, it is very hard to balance the stator and rotor, because stator and rotor, sorry. This one is very difficult to balance. So you cannot just an empty refiner. It's very risky because you might damage the segments. You can damage the segments, and even the measurement that you do, the pulping effect will not be very uniform. Basically the hydraulic load that is developed on an empty refiner, it has been done in many studies. Just to theoretically calculate it. If you try to practically do it, it's very hard to sense the exact power consumption during that point. So it's no load calculation, we can do that. And in case of artificial intelligence, what will happen is, depending on the different furnish, we'll give a different range of energy input to the refiner as a set point. And depending on the freeness result coming out of the freeness analyzer, it will automatically evaluate what should be the right energy that can be inputted here. When we do this manually, it is very hard to get a right number because one, we do not have instantaneous freeness results also. Number two, there are a lot of things hidden from our view that is very hard to establish. Like if you calculate 300 kilowatt, generally we keep around 25% extra, 330 or 340 kilowatt. All this goes as an energy waste. Whereas in this system, you get a freeness at a very short periods. And based on that, the system will also, algorithm will also evaluate what should be the right refining. We can keep a very, apart from that, we can give a very low margin like 5% or 10%. So if you calculate 300, you can keep just 310 or 305. This way, you can save a lot of energy. Yeah, any questions? Should we take now? Yeah, we can take now. Is multiple sensors required when the 3 refiner running in series parallel mode? Yes, as I said, around each refiner, you need to have connected, whether in terms of flow or differential pressure at inlet and outlet of each refiner, temperature at inlet and outlet of each refiner, vibration sensors. So all these sensors, multiple sensors are required. If any existing sensor is there already in the mill around that, we can utilize that. Where it is not available, we have to add it either by customer or by we can do that. That is one. Have you, do you have this installed and operational in a paper mill? No, we are just, we are working on it. Very soon we will be having it. Right now it is on concept mode. How do we calculate inch cut per minute in automatic system? I don't get the question. Inch cut. I don't know. I'll take it later. I'm not sure what the question is. I'll come back to you later. And optimum SC load for hardwood and softwood. Yeah, like I said, each furnish has its own range. The one big advantage here is we are not going to tell what should be the exact amount of SE load that you have to provide. There are two things that consider. One is a proper no load calculation for each of the refiner. Sometimes support from your supplier is also required on giving the specific edge length and all that. And then we will carry a specific edge load can be calculated. Based on it, how much energy is to be given, that the automated algorithms will determine. We will provide a range, like you must be already operating it in a certain range, like 3 to 4 kilowatt per hour or so. We'll give it a range of 3 to 5. So the system will choose the algorithm depending on the freeness result that it is getting. So we will not be interfering into that. Do we expect repeatability to the freeness result as the sample is transported to a centralized? Yeah, it can be done. It is based on what is verified, and it will not be far away also. The sample freeness analyzer will be installed very close to the refiner, as close as possible. I think there should not be any drop in this one, and that has been, so that is something that will be guaranteed by the freeness analyzer supply. And what is the importance of the recirculation of a refiner? Very much important. I mean, this knowledge is available in a public domain as well. So I think in order to save time, I'll keep it away. However, you can mail to us separately, we can provide the answer. When Haber will offer this system for market? Yes, it is available now. Except for that, you have to factor in a lead time of 12 to 16 weeks. That is all for the after decision. And is raw material mix a factor during calculations? Yes, but again, we can, if this is a very specific thing, we can experiment, we can keep it in observance mode, we can try different raw material mix, and that the algorithm can identify how each of the raw material is affecting your final results. Can be done. Which refiner should be set at first in single? So we don't know. Basically, we need to do a survey for each of the system. We will determine after that. Is the refiner directly controlled by you, or you send a set point to the Freeness control program of the refiner supplier? So basically, we will go from the Freeness set point, like we say. We have an advantage that we can link it to a certain paper properties, or by your experience that for certain paper grades, this is the Freeness that I'm getting better. One, we can start from there, which Freeness set point. Secondly, we can also experiment later. Suppose you do 45 degree SR, whether 43 is good for it or 47 can be done also. And depending on this one, we give the set point for the Freeness analyzer. What set point? It can be changed. Tomorrow we can try different things because you have the advantage of a good comparison of different data points. Then later on select the best Freeness for a certain grade. And directly, in order to set your questions, we don't directly take your directly control the refiner. Invariably, Elixa communicates to the DCS, and DCS, whatever is your existing system of controlling your refiner, that will remain the same. The Elixa will only advise the DCS to do certain changes. Yeah.
Mr. Ram, please unmute.
Yeah. So I hope I have covered most of the questions. So if there is anything further, you can still write to us, not an issue, or we can at the end of the session. So widgets. So widgets are basically something that it's like your dashboard that we do, that we have done in Elixa for many of the other applications as well. Particularly here, when you have more visibilities, more parameters or trends that are visible on your dashboard immediately near the refiner DCS room, you have better control of the refiner. So in order to that, there is actually no limit of number of widgets that you can have, but depending on certain, what you can do is certain things you can see very quickly online, certain things, major calculations you can see in order to not to load your Wi-Fi, you can see later also in the records or download it as Excel or CSV files and observe. So basically you have a number of very important things around the refiner like production rate, recirculation percentage, refining hours, freeness. These are just general plant data. So these can be made visible very immediately on your dashboard. Then there are certain comparative trends immediately. We may for the minute by minute trend process like freeness and feed rate, freeness versus consistency, all these comparisons, you don't have to do a post-mortem exercise. These are available per second on your screen. So that will be the another advantage. Similarly, on condition monitoring, we can have a vibration analysis of your refiner. Any sharp vibrations in the refiner casing or around near the plate areas can be detected. Refiner bearings can be observed, and water bearings can also be. The idea here is not to do a full-fledged vibration analysis here. We can do it, but probably we'll restrict it to a minimum. But the idea here is just immediately perk up on something different. What we'll do is highlight certain things. If it is going slightly different, then you can have a physical evaluation whether lubricant is going or is it some other reason can be done. This is like tailor-made. So this is how the widgets will look like typical for any application, a daily production, and how is it depending on comparative to the previous days or to the previous months, everything. A very quick view of your daily production, your total energy consumption, and how many days since your last segment change, and your maintenance history, how many days since your last maintenance. These are the things on the production level. And we can even, we can have feedback on like how much production has happened per segment since it's installed. So this way we can even compare back-to-back different segments from different suppliers, etc. also, or a different design of segment. This can be done. And energy consumption, like here, you can compare different trends, energy consumption versus flow and consistency. Anything, and there is an option. You can, in this, like if you say you don't want to see consistency, you can switch it off. And you can see only flow rate and energy consumption. Similarly, if you don't want to see flow rate, you can switch it off at a click of a button. You can see consistency and energy consumption. Like that. And here, vibration sensors. So this is a typical refiner where we will have a vibration sensor near the plate segment area. Any clash or anything will cause a certain vibration. We can pick it up. Then invariably it so happens when something creates a vibration here, this is transferred onto the refiner bearings. Bearings can also have their individual own faults, maybe due to lack of lubrication or some foreign particle gone inside. These vibrations will come. Now this will get an advantage, like if there is a sink or if there is a microsecond beginning of here near the plate clash vibration anomaly near the plate clash, and then the bearing, this one, so we can easily detect that some bearing load has been created from inside the refiner. Otherwise, if there is not much vibration here, then if there is because of bearings, then we can inspect the bearings for any lubrication or any foreign particle assessment. Then there will be, because these are high powered motors, there will be a bearing, a drive end bearing sensor, non-drive end bearing sensor. So all this, so you can have a trend of this also. There are two ways of seeing this. One is what we call the raw data from the vibration sensor. As it picks up, it is transmitted, it is evaluated, and a trend can be made. Or where required, depending on customer, root cause analysis, if needs to be done, we can have a Fourier transform analysis, FTT analysis done also. Based on which you can find a root cause analysis for each of the vibrations. Yeah, sorry, please ignore the red lines that is showing up. We don't know where the source of it. And then coming to gap sensors. So this is typically shown for a conical refiner here, the drawings, but in a tri-disc refiner or a double-disc refiner also the funda is same, only how we mechanically install it will vary. That we will survey for each machine and identify. So basically here we will calculate the sensor capability based on your typical erosion of your erosion thickness of your stator and rotor, whether it is 5 mm, maximum 5 mm or 8 mm or anything like that. So we will evaluate it, then have it installed here. This will continuously give what is the micron difference between stator and rotor. And as the gap increases, we can also analyze whether the erosion in the segment, that is, say your segment is coming for 90 days, we can analyze the energy that is needed within the first 30 days or 30 to 60 days or 60 to 90 days as well, depending on the erosion level. And more importantly, there are several times the segments are removed based on based on past experience. Okay, last time it came for 50 days, so I should now remove it at 48 days or 50 days, we should be ready to remove. Here in this case, it may not be necessary because we will be really assessing the erosion level, and that only at some point we can detect, yes, it can be a planned shutdown. Yes, the segment has to be changed. That will be a way of extending the life of segment, or like I would say utilizing the segment's life more efficiently, and then change the segments. Similarly, we can compare different patterns of segments, design changes. You can have more clear clinical assessment of what a different design change is doing. And, yes. So we can have multiple redundancy in the gap sensor also. So depending on that, we have tried, I think most part, and we are trying to correct. Probably there are very limited options in the market, in the world for gap sensors. I think we'll be able to give it a more affordable alternative. But the participants are there. 139. I'm able to see the photograph.
Go ahead, please. Go ahead.
Yeah. Before we go into ROIs, at this point, can I take any questions? Is the chart options?
Please go to full screen mode, please. Full screen mode.
Yeah, I'm just taking a break for questions. So is there a chat options? Chat, yeah, chat 30. Yeah, one second. Let me
Yeah.
go back to see.
Whether this refiner control package includes fiber morphology measurements, that's a question to you.
Yeah, it can be made because it is only an added instrument. This can be tailor-made. Like I said, you can have a freeness analyzer, you can have a fiber morphology analyzer, or you can have both. It can be, package can be tailor-made. Is LMP a better option than non-contact type proximity sensor? No, right now we are going with this based on other, but in future we'll keep our options open. We're also good at deep dive. Can you show live example? We don't have right now, but this minor package is in concept stage. But whatever we are proposing, this basic, this algorithm for doing any process optimization, we have live projects involved in doing a process, like we have for a pulp bleaching plant. We are getting a very clear pulp, brightness targets in the dosage, retention time, etc. And we are getting a very, very bandwidth of pulp brightness. So basically, this method of algorithm development, it's only like a software. And even if we notice certain error, this can be corrected in our next version of the software. So nothing that goes wrong terribly. Basically, we can do continuous improvement all the time. It is possible. And is refining enzymes retain the final strength properties? Yes, instead of me saying it will work or it doesn't work, what this program can do is to make a better judgment of comparison between with and without refinery enzyme or whether two different refining enzymes. What it can do now that you have more data to compare, keeping other things, we can pick what the refining enzyme is really affecting about, and we can give you a better analysis so that we can remove the judgmental errors in that. Some concept comments on machine refiner located in approach flow system. I think it is all the same. Like I said in one of my slides, irrespective of the position of the refiner, we will discuss with the customer on what is the more core important thing around that refiner. What is it they are trying to do, even if it is a proper refiner freeness race. We will discuss, depends on what comes out of the survey. What is important, we will focus more on. Yeah, I think all questions are done. Yeah, I'll go back.
I am hearing a child's voice and a lady's voice, despite everybody have been muted. Can somebody help us, please? Please go ahead.
Yeah, so coming to, after doing, I hope this concept is clear. Now, return on investment. So it is little back and forth. Particularly, there is not a big investment in the first place. You don't have to invest, but I'll come to that later. But the return on investment, we will give the first priority. Like we said, there are everywhere it has been written as well that one of the most important operations within the paper industry is a little blind. We don't know not much that is happening around the refiner. One of the best return that you get from this concept will be, the first thing is the knowledge around every aspect of how the refiner operates, then monitoring. We'll go to the monitoring next. But like if you can, like I've written here, there are different options that you can compare. Grade versus properties versus the big data crunching. Basically, from the data, it is generally not possible like we do a post-mortem Excel sheet analysis or anything. But here, we get a live analysis of the situation. And we can draw out any kind of report that we want, compare anything to anything, whether it has an impact or the algorithm itself sometimes will find a match. If we can put it on observation mode, algorithms will find which one is affecting by what percentage more on your final end results. So likewise, I have written here some about comparison of different aid with a certain specific focus. Like you want to identify optimum freeness or optimum furnish or optimum viscosity. So this can be done. This will be a great tool in the hands of paper maker and it will take your time away from, even if it's an old system, you can once again reset it to a very new, different level of knowledge or new level of different level of operation. That will be the advantage here. And typical what you do many times when we say that a paper machine we do not able to run because probably there will be a lot of breaks as we try to, when it will be running well for an hour, then when we try to increase the ash percentage or try to take advantage of it, the paper break will start. Then by doubt, we will get back and we will even give a lower ash target than what was actually running. So we will be going back and forth. Who knows, maybe within that 1 hour, the freeness was changing or anything like that. So depending on that, once we know that we are able to, first thing is to get a whatever freeness that we want. If we are able to maintain it consistently, then it is possible that we can have a controlled increase of sheet ash. So we feel that even about a 1% sheet ash increase is a very practical target. Even if you do that, most of you will have a good return on your investment. And then a very nominal 10% tackle life we are putting. Like I said, it can be two ways. It's not necessarily, one is planned. When you take out the tackle, can be a little more planned than what we do now. So you might get some saving. Then the amount of information that the gap sensor gives you, we can avoid a lot of erosion, particularly the vibration sensors as well as the gap sensors, the information they give. And also based on other parameters. So first you are running the refiner properly with the flow and consistency. So that will enable to give a better tackle life. We can extract more from the tackle. And the third is machine efficiency. Of course, we can avoid the breaks, and it depends on each machine that what we take and what impacts the machine operation, we can take it for observation. So this, I mean, basically all these advantages are available, I think, across the grades. It can be done. Some case it may be partial, like in board grade, because maybe filler layer, you may not be doing refining much or focusing on that. So there the saving may be a little partial. But apart from that, across the grades, you should be able to get some benefits. So the general, this is about how we do it part. Like basically, like I said, the question of return on investment, there is no real big capex investment from the paper mill side. Usually Haber does it. And we only charge a monthly rental. That is the months per, basically that you pay on performance. You see our performance and you are paying every month. And it can be different tenures, different options, depending on the investment, you can, or features that you require. There can be a flexible tenure greater than 36 months. And we are also flexible that any field instruments or any particular specialty instruments that you need, if you are not able to procure, we will put it as part of our package. And so it will basically be a win-win model that you have fixed monthly rental. So it doesn't give you extra. Basically, it removes the risk out of your investment. That is the big thing, expensive investment. and benefit sharing, whatever benefits that arrived at, that we can share equally. So this is the concept. So how do we do it? Like it is implementation is first we have to do a survey of your system, then identify your goals, what are the problems and what are the things that you face, what is more important to you, what are the pain points for you, and then identify alterations to the existing system setup. Like I said, the flow, consistency, everything, whether will it happen as per our desire or not, any small changes, and then complete the required field instruments, and then developing a system to upload manual data online. These are things we need to discuss, and identify ROI possibilities. All this if we done, we are ready to, and then basically the lead time of the items to come.